Everyday Mathematics. Today we look at the 2024 Columbia University Integration B qualifying round, and we'll be focusing on part one that involves solving the first 10 problems of that qualifying round. So these are very interesting problems, and hopefully as we solve this problem, you could benefit from some of the steps we introduce. So without much ado, we'll move forward and start solving these problems. For problem number one, which is the indefinite integral of sine squared of x over cosine of x, this is how we may be able to solve it. So first thing is I could express sine squared x as 1 minus cosine squared of x, right? And then we have cosine of x. So this becomes secant of x minus cosine of x integrated. So this is a well-known integral, and that is the natural logarithm of the secant of x plus the tangent of x minus sine of x plus the integration constant. And that is the answer. So obviously one question that one may ask is, how does the integration of secant of x come to be that? So this is just a, by the way, integration of secant of x is the same as the integration of 1 over cosine of x. If you happen to have a denominator that is a trigonometrical function, in most cases you want to use the substitution, let t be equal to tangent of x over 2, right? And so if you have a triangle over there, the best angle is x over 2. It means that our opposite is t, and the adjacent is 1. Hypotenuse is 1 plus t squared square root, such that cosine of x, which is cosine of x squared minus sine squared x over 2 is equals to 1 over 1 plus t squared, this over that, minus t squared over 1 minus t squared. And the other thing to note from here is that dt dx is half of sec squared x over 2, meaning that if t is equals to tangent of x over 2, then dt dx is equals to a half sec x over 2, and so 2 dt over sec x over 2 is equals to dx, which means that 2 over 1 plus t squared, because 1 plus tangent of x squared, dt is equals to tx. So that if our problem is 1 over cosine of x integrated. This is the same as 1 over 1 minus t squared over 1 plus t squared. This times 2 dt over 1 plus t squared. So which is the same as 1 plus t squared over 1 minus t squared 2 dt over 1 plus t squared. And that cancels, so we have 2, the integral of 1 minus t squared, which is equals to 2 over 2, 1 minus t plus 1 plus t. So we're expressing this as partial fraction. And so our problem is 1 over t plus 1 over 1 plus t integrated, which is log 1 minus t plus log 1 plus t plus the integration constant, which is equals to log of 1 plus t over 1 minus t plus c, which is log of 1 plus tan x over 2, 1 minus tan x over 2 plus c, which is equals to log of cosine x over 2 plus sine x over 2 plus cosine x over 2 minus sine x over 2 plus c. So we have log of cosine x over 2 plus sine x over 2 cosine x over 2 minus sine x over 2 plus c. Multiply both the numerator and denominator by cosine x over 2 plus sine x over 2, so we get cosine squared x over 2 plus sine squared x over 2 plus 2 sine x over 2 cosine x over 2 over cosine x over 2 minus sine squared x over 2 plus c. So this becomes 1 plus sine x over cosine x plus c, which is log sec of x plus tangent of x plus c. And that kind of proves that. Usually this is something one would memorize and know off the top of their head. So without much ado, let's move forward. So problem number 2, which is the indefinite integral of the square root of x squared plus 1 over x, may be solved in the following manner. So my first inclination is to say let x be equal to the hyperbolic sine of u. And what does that mean? It means that dx du is equals to cosh of u. Therefore, we can substitute for dx with cosh u or hyperbolic cosine u du. So that's an important first step. Then the next step is to now go ahead and say, okay, if this is what we have in the x domain, right? This becomes square root of hyperbolic sine squared u plus 1 all over the hyperbolic sine u times the hyperbolic cosine u du. And this becomes at the very top, we do have cosh u over sinh u, like that. So essentially we just have the square of a hyperbolic cosine of u over the hyperbolic sine of u integrated. Okay, so one other thing to note is that if we have that as our numerator and that as our denominator, this becomes 1 plus the square of hyperbolic sine of u over hyperbolic sine of u, which becomes 1 over the hyperbolic sine of u plus hyperbolic sine of u. This part is easily integratable, but this part, I think what is important is for us to express this as in form of that, right? So we have 2eu minus negative u du plus, this is already a known thing, so we don't want to waste time there. Our problem now becomes integral of 2e to the u minus negative u plus cos of u plus c. If we multiply both the numerator and the denominator by e to the u, we get e to the 2 times e to the u, 2 times e to the u over e to the 2u minus 1 plus cos u plus c. And so we can also express whatever we have here, since just to expand this is the same as 2 times e to the u plus 1 plus c, and we can pull 2 out and e to the u out of the bracket. So we see we have 1 over e to the u minus 1 over e to the u plus 1, such that we have 2 remaining in the numerator, and to cancel that we put a half outside, cos u plus c, and these two would cancel out. So we eventually now have e to the u over e to the u minus 1 minus e to the u over e to the u plus 1. That's cos u plus c. So this first integral, it's easy to see that we have natural logarithm of eu minus 1 minus natural logarithm of eu plus 1 plus cos u plus c. So this becomes natural logarithm of e to the u minus 1 over e to the u plus 1 plus the hyperbolic cosine of u plus c. So we had said that let iu be equal to hyperbolic the inverse of x, or let's that be equal to x. What that means is that e to the u minus e to the negative u over 2 is equals to x, meaning that e to the u minus e to the negative u is equals to 2x, and so e to the 2u minus 2x e to the u minus 1 equals to 0. Since e to the 2u minus 2x e to the u minus 1 equals to 0, what that means is that e to the u is equals to 2x plus minus 4x squared plus 4 over 2, which is equals to x plus minus x squared plus 1. Now notice e to the u is always greater than 0, so we are going to choose x plus x squared plus 1 as our option. So if our answer is log of e to the u minus 1 over e to the u plus 1 plus cosh, which is the same as 1 plus hyperbolic sine squared of u plus c, we just now say our integral is x plus the square root of x squared plus 1 minus 1 over x plus square root of x squared plus 1 plus the square root of 1 plus, since u is x, comes x squared plus c. And that there, ladies and gentlemen, is our final answer. Problem number 3, the indefinite integral of e to the square root of x. I think the first thing is for us to substitute for the complex part, and by complex I mean the complicated part. So I'll just say let u be equal to the square root of x. What that means is that u e squared is equals to x, meaning that 2u du dx is equals to 1. And that implies that we can substitute for dx with 2u du. So this is an important step. And so our problem becomes e to the u 2u du, which can be expressed that way. So we can now also express this as, since the derivative of e to the u is the same as e to the u, and using integration by parts, where we say that if you have an integral of a product of a function v and the derivative of a function u, that integral is uv minus the integral of the function u times the derivative of function v. In our instance here, u happens to be e to the u and v happens to be u. So in other words, we have 2. The product of u and v is going to be u e to the u minus the u is going to be e to the u. The derivative of v is u. The derivative of u with respect to u is 1. And so that is our integral, right? So we do have now 2 u times e to the u minus e to the u plus c, which means that we have 2u e to the u minus 2 e to the u plus c, but we said u is equal to the square root of x. Therefore, the integral of e to the square root of x is equal to 2 square root of x e to the square root of x minus 2 e to the square root of x plus the integration constant. And that, ladies and gentlemen, is our answer. For problem number 5, the indefinite integral of x to the 5 over x to the 4 plus 1, we can solve it for it like this. So I'll pull x out here so that now I have x to the 4 over x to the 4 plus 1. And what that allows me to do is I'll say, okay, x, we can have this as x to the 4 plus 1 minus 1 over x to the 4 plus 1, which is x to the 4 plus 1 over x plus 1 minus 1 over x to the 4 plus 1. So you see this and that cancel, so now we have x minus x over x to the 4 plus 1. So which is the same as x squared over 2 minus the integral of x over x to the 4 plus 1. Right? So we get x squared over 2 minus x over x to the 4 plus 1 integrated. And how we could work on the second one, we'll just say this is the same as x squared plus 1. And for the second one there, we can say let u be equal to x squared, meaning that du dx is equals to 2x. And so half of du can be used to substitute for x dx. Very important. So in other words, we now have x squared over 2 minus a half du over u squared plus 1, which is x squared over 2 minus half. This is a very famous integral, arctangent of u plus c. And since we have x squared over 2 minus a half, arctangent of u plus c, we know that u is equals to x squared. Therefore, the integral of x to the 5 over x to the 4 plus 1 dx is x squared over 2 minus a half arctangent of x squared plus integration constant. And that, ladies and gentlemen, is our answer. So for problem number 5, the indefinite integral of arc sine of square root of x over square root of x. This is an interesting one. So as we always do, we try to substitute for the complex or the complicated part. So we just say let u be equal to the square root of x such that u squared equals to x, and so 2u du dx equals to 1. And so meaning that we can substitute for the x with 2u du. Okay, so our problem, arc sine of the square root of x over the square root of x is equals to, in place of the arc sine, would have arc sine of u over u 2u du. And we see that. So we have 2 integral of arc sine of u. And we'll say let y be equal to arc sine of u, which means that sine of y is equals to u, and therefore cosine of y dy du is equals to 1, meaning that we can substitute for du with cosine y dy. Okay, so since we came to a point where our problem was twice the arc sine of u, the integral of arc sine of u, and we had seen that if y equals to arc sine of u, then dy, cosine y times dy would be equal to that, to du. Since we had come to that point, then it means our problem now is 2 twice arc sine is y, du is cosine of y dy. And that means that now we can also express cosine y as the derivative with respect to y of sine of y. And then if we are to remember our integration by parts, where if you are integrating the product of v and the derivative of function u, we get uv minus u times the derivative of v. So with that in mind, our u being sine y and our v being y, then we have 2 uv is y sine y minus our u is sine y, our v is y, and so dv is going to be derivative of y with respect to y, it's going to be 1. So that is our integral, which is 2y sine y minus, actually plus cosine y plus the integration constant. Now, since we've come to that point, and we know that y is equals to arc sine of u, we know that. It means that our problem is 2 arc sine of u times sine of arc sine of u plus twice square root plus 1 plus sine squared arc sine of u plus c. So this is 2, this is definitely u, so we have u arc sine of u plus 2, 1 plus u squared plus c. But u was equals to square root of x, so answer now is in the x domain, twice square root of x, arc sine of the square root of x, plus twice square root of 1 plus x plus c. So we can say that if we're integrating arc sine of square root of x over square root of x, we get twice square root of x arc sine of square root of x plus twice 1 plus x plus the integration constant. And that, ladies and gentlemen, is our answer. Problem number 6, right? The indefinite integral of e to the x plus 1 over e to the x minus 1. So one thing we could do is just say, okay, this is the same as, the numerator is the same as e to the x minus 1 plus 2 over e to the x minus 1, which is the same as e to the x minus 1 over e to the x minus 1 plus 2 over e to the x minus 1, which is 1 plus 2 e to the x minus 1. The important part here is we have x plus the integral of 2 over e to the x minus 1. So which is the same as x. I can divide both the numerator and denominator by e to the x, and so we get 2e to the x over 1 minus e to the negative x, right? So since we have our problem, as follows. This is the same as x plus twice the natural logarithm of 1 minus e to the x plus the integration constant. And obviously this could also just be expressed as twice the natural logarithm of e to the x minus 1 over e to the x plus the integration constant. So e to the x plus 1 over e to the x minus 1 is the same as x plus twice the natural logarithm of e to the x minus 1 over e to the x plus the integration constant. And that is the answer. So the next problem, the indefinite integral of the square root of e to the x times the square root of e to the x. First, I think the important part here is that we express it in a way that is easy to visualize. So we have e to the x times e to the x to the power 2 or to the power 2. So this is the same as e to the x e to the x a quarter. So we have e to the x a half plus a quarter is 3/4. And we can say let u be equal to e to the x. So du dx is equals to e to the x. And so du over u is equals to dx. So this is an important part because now we say, okay, we have u to the power 3 over 4, dx is the same as 2u over u. Okay, so let's continue. So since we have u to the power 3 over 4 times 2u over u, this is the same as u to the power a quarter, negative a quarter du. So how do we proceed with that? That means that our answer is 4 over 3 u. Negative a quarter plus 1 is 3/4 plus c. But we said u is equals to e to the x. So in other words, this ugly integral is the same as 4 over 3 e to the x 3 over 4 or 4 over 3 e to the x plus c. And that is it. Okay. Problem number 8 is the indefinite integral of 1 over 1 plus sine x plus cosine x. As is the practice, whenever you see a sine x, cosine x in the denominator, the first inkling would be to use a tangent of x over 2 as our substitution. So we would say let t be equal to tangent of x over 2. What that means is that dt dx is equals to a half sec x over 2, which means that we have 2 dt over sec squared x over 2 is equals to dx, and this is the same as 2 dt over 1 plus tangent x over 2, which is equals to 2 dt over 1 plus t squared is equals to dx. So an important substitution, right? And then we see that we have our triangle x over 2. tangent is opposite over hypotenuse, so t over opposite over adjacent, so we have t over 1, and then the hypotenuse is 1 plus t squared. What that means is that cosine of x is the same as cosine squared x over 2 minus sine squared x over 2, which is cosine squared x is 1 over square root of 1 plus t squared, which is 1 over 1 plus t squared. And then sine is opposite, so t squared over 1 plus t squared. Right? And then sine x is equals to twice sine x over 2 cosine x over 2, which is 2t over 1 plus t squared. So therefore our problem, integral of 1 plus sine x plus cosine of x is equal to 1 over 1 plus 2t over 1 minus t squared plus 1 minus t squared over 1 plus t squared. 1 plus t. And then dx is 2t dt over 1 plus t squared. So this is the same as when we multiply both the numerator and denominator, we get 1 plus t squared in the numerator, and we have 1 plus t squared here, plus 2t plus 1 minus t squared, 2 dt over 1 plus t squared. That and that cancel, so we have the integral of 1 over 1 plus t squared plus 2t, this one here, plus 1 minus t squared. This and that would cancel, so we have the integral of 1 over 1 plus 1 is 2 plus 2t, and we have dt there. We have a 2 here, so we can bring the 2 out here. But we see that these 2 and these 2 would cancel. So our problem now becomes the integral of 1 over 1 plus t, which is the natural logarithm of 1 plus t plus c. And since t is equals to tan x over 2, we have 1 plus the tangent of x over 2 plus c. So in other words, our integral of 1 plus sine x plus cosine of x is equals to the natural logarithm of 1 plus tangent x over 2 plus c, or natural logarithm of 1 cosine x over 2 plus sine x over 2 over cosine x over 2 plus c. We can even simplify it further. So since we said this is the same as log of cosine x over 2 plus sine x over 2 over cosine x over 2 plus c, multiplying by sine x over 2, both numerator and denominator, we have cosine x over 2 sine x over 2 plus sine squared x over 2 over cosine x over 2 sine x over 2 plus c. This is the same as log of a half sine of x plus a half cosine of x minus 1, rather 1 minus cosine of x minus minus cosine of x plus a half sine x rather. See, this and that would cancel. So we have log of sine of x plus 1 minus cosine of x over sine of x plus c. I think that's fairly simple. Let's leave it at that. Problem number 9. An indefinite integral of 1 over cosine of x times cosine of 2x. Now, I must say this is a pretty tricky problem, but let's see how we may be able to solve it. So this is the same as the integral of 1 over cosine of x. And let's choose to express cosine 2x as 1 minus 2 sine squared of x, right? And so we say let y be equal to sine of x such that dy dx is equals to cosine of x, and dy, right? So we can express this problem as 1 over cosine squared of x 1 minus 2 sine times cosine of x dx. So that this is dy, and here this is 1 minus sine squared x, which is 1 of y squared, 1 minus 2 y squared dy. So we could express this as a partial fraction because we begin with the smaller one, so we have 1 2y squared, so that I think we want to express this is 2, so that this is 1 minus y squared dy, so that when we combine it we have 2 times this, which is 2 minus 2y squared minus 1, and so yes, that works out. The problem now becomes 2 over 1 minus 2y squared minus 1 over 1 minus y squared, which can be expressed as 2 over 1 minus square root of 2 y squared minus 1 minus y squared, which is the same as 2 1 minus root 2y 1 plus root 2 minus 1 y 1 plus y. So this becomes partial fraction 1 over 1 minus root 2y plus 1 over 1 plus root 2y divided by 2 minus a half 1 minus y plus 1 plus y dy. So these cancel each other, And so essentially we can even separate that into two separate integrals. So we have integral of 1 minus root 2y plus 1 plus root 2 of y dy is a half integral of 1 over y. Let's probably just bracket it out because we have y dy. So this is interesting, very interesting, because now we do have negative 1 over root 2 natural logarithm of 1 root 2 y plus a half natural logarithm of 1 plus root 2 of y minus, this is root 2, minus a half, minus we have plus, log of 1 minus y minus a half natural logarithm of 1 plus y plus c. So this becomes 1 over root 2. We can consolidate this first part here. So we have natural logarithm of 1 plus 2y over 1 minus root 2y plus a half natural logarithm of 1 minus y over 1 plus y plus c. But we said y is equals to sine of x. So what do? We say that our integral, which is integral of 1 over cosine of x times cosine of 2x is equals to 1 over root 2 natural logarithm of 1 plus root 2 sine of x over 1 minus root 2 sine of x plus a half times the natural logarithm of 1 minus sine of x over 1 plus sine of x plus the integration constant. And that, ladies and gentlemen, is our answer. Quite winded, but interesting all the same. So on to problem number 10, which is indefinite integral of the square root of 1 plus tangent squared of x. We could always write this as the integral of the second squared of x. Another way of writing this is, because this is just looking for the absolute value of secant of x. And how do we solve that? So we could reintroduce this new function. This is this sine of x, which means that when secant of x is negative, this is going to be negative. So that's, in some way, it's a hidden constant. So we define secant of x to be equal to -1 when secant of x is less than 0, 0 when 0, 1 when is 1, right? So we've defined that as that. So this is just going to be equal to the integral. In a way, this is a constant, So the integral of secant of x is just a well-known function, which is the natural logarithm of secant of x plus the tangent of x plus the integration constant. So that is that. Right. So another way of probably writing this is just saying, okay, we will get secant squared of x as it is and divide by secant of x, right? And that will give us that sign. But other than that, this is our answer. Okay, so that was a simple one. If you have any question, we do really encourage you to reach out to us. Please feel free to send us a message or just leave a comment in the comment section. If you do like what we're doing, please don't hesitate to leave a like. Please subscribe if you haven't subscribed. Other than that, it was an absolute pleasure hanging out with you. Until next time, bye bye.